Okay, are you getting the hang of it yet? Let's do the next one. I see 1 of 2's of something, 1 and 2 of something. So I know that if it's going to be anything, it would have to be double replacement, okay? So I say, all right, so what could possibly be my products? Let's go ahead and write that down. So I'm going to say Na, outside, outside, SO4 plus Cu, CO3, but now I have to worry about the subscript. So I say Na is plus, SO4 is a 2 minus, so I'm going to say Na2, SO4. Cu, CO3, I don't know what Cu is, but I know the CO3 is going to be negative 1 because the negative 2. So I'm going to say like this, and then I don't know what that is, but I see over here that this was bonded to this one, and it was just 1 and 1 ratio, so most likely this is just a 2-2, so this one can just stay the way it is. All right, so let's move forward, and we're going to say, all right, so the next step is to figure out if this one or this one formed a precipitate. So let's find that out using our solubility charts, okay? So we're going to come up here, and then we're going to say, all right, so anytime I have group 1 metal, group 1, it is all soluble, no precipitate. I don't need to look further. I say aqueous and be done with it. Now, copper carbonate. This is the one that where I have to look, and I say, all right, all the carbonates, it's the last one. It is going to be insoluble, so they're going to form a precipitate. So this one is going to be a solid. So I say, all right, so this one did form a solid, which tells me then it is going to be a reaction, and so it is a double replacement reaction, and so I know that far. The next one I have to do is to write the net ionic equation. So remember, keep everything that was solid. Aqueous, aqueous, nope, that's solid, yep, got to keep that in there just the way it is. And this one's charge is nothing because this is a compound, so no charge, so leave it alone. Now come to this side, and I have to put what made it possible for me to have copper and carbonate. So I'm going to say, all right, so I had copper from here, okay, but let's turn that into an ion. So this one's charge then is going to be a 2 because I know if it's like this, it's 1 and 1 ratio, so I don't have any more subscripts. So I'm going to say this one, okay? Then I'm going to say, all right, and this was aqueous because I get it from here. And then the next one that was in charge was this one, so I put that there. And what's its charge? I'm going to say, well, that's just negative 2, because carbonates, all carbonates are 2, and that's the reason why this one has a 2. And what was the charge? What was the state of matter? It was aqueous. And I have to look and see if everything is balanced out, because if it's not, then I do have to put some coefficients here, okay? So let's do our charge thing. Here, it's 0, okay? Here I have plus 2 and a negative 2, which makes it a 0. Another way to check it is like just check how many of each I have. I have this one and this one, this one, this one. So I'm doubly assured that this is all balanced and it's good to go. So this would be my net ionic equation, and the type would be double replacement.